All right, how's it going, class? So here's what we're going to do today. We're going to talk about predicate logic, symbols, and translation. I've elected to do this via a podcast with PowerPoints to abandon so that you guys don't have to look at my horrible handwriting and can actually understand what you're looking at. So we're going to give this podcast a try. Feedback will be appreciated. Anybody that checks this out and decides that it doesn't work, let me know. Maybe I'll go back to working in front of the board, but I felt like this would work out for all of us. So again, predicate logic, symbols, and translation. Let's get started. So the fundamental component in predicate logic is what we call the predicate, of course. And we symbolize predicates by using uppercase letters A through Z. I'll talk a little bit more about this as we go on. But the notion is that any sort of predicate that we're discussing or translating, we're going to use an uppercase letter A through Z to signify that particular thing. We're going to call these predicate symbols. So here's some examples. I'll put the English predicate on the left, and we'll put the symbolic predicate on the right to give you an idea. This is similar to what you'll see in your textbook as well. So on the left, I have blank is a dancer. On the right, I have a capital D, which stands for dancer, and a blank. In these blank spots, what we'll do is we'll put a lowercase letter that will represent the subject of the statement. So for instance, in the first example, I have D blank. If my sentence was Kingard is a dancer, then I would have a lowercase k with the uppercase D. I'll show you a few of these in just a moment. Okay, but the notion here is that the predicate letter will be symbolized, or the English predicate will be symbolized by a predicate letter, and the predicate letters are A through Z capital. All right. Now, before I get into the translations in depth, what I'd like to explain to you is about three different kinds of statements. We have singular statements, universal statements, and particular statements. We'll go through each one of these now in order. So first, singular statements. A singular statement is a statement that makes an assertion about a specifically named person, place, thing, or time. When we're translating a singular statement, we use lowercase letters corresponding to the subject of the statement to the immediate right of the uppercase letter. So recall when I was discussing the predicate letters, they're the uppercase letters A through Z. The subject letters will be lowercase letters A through W. We call these individual constants. So the individual constants are lowercase letters A through W. They're the first 23 letters of the alphabet. Don't be concerned if at this moment you're kind of cloudy as to what's going on. I will show you examples before it's over. I just want to make sure first that we get some of the terminology down. So predicate symbols are capital letters A through D or A through Z, and individual constants are the lowercase letters A through W. Again, these are called individual constants. So let's look at some examples of translated singular statements. Now remember, singular statements are always going to involve the name of a person, place, or thing. So if I say, for instance, that Dave is gassy, my predicate letter is going to be capital G, and my subject is going to be lowercase d. Notice, Dave is my subject, gassy is my predicate. So when I translate the singular statement, I translate it with an uppercase G and a lowercase d. Now I know this may seem a bit counterintuitive because in the statement, Dave is to the left of the word gassy, but you're just going to have to get used to that. The symbolic translation always uses the predicate letter to the left and the subject letter to the right. So let's look at a few more. Tennessee is smoky. I have a capital S for smoky and a lowercase t for Tennessee. Hitler is an ass. Uppercase A for ass, lowercase h for Hitler. So again, notice that the predicate is the uppercase letter on the left and the subject, of course, is the lowercase letter on the right. Again, on the left is the predicate symbol, on the right is what we call the individual constant. Marley is not an ass. So we should be familiar with this negation sign, but by putting the negation sign in front of me here, I'm saying it's not the case that lowercase m Marley is an ass. Ass being the predicate, Marley being the subject. Okay. Now, we should be fairly familiar at this point with all our different operators, and the conditional operator, the disjunctive statements, conjunctive statements, biconditionals, all these operators that we've been using in propositional logic carry over to be used in predicate logic as well, and they will allow us to make more compound singular statements. Notice that I'll back it up for a second. These statements here that we're using are very simple statements. Dave is gassy. So it's simply the lowercase d, individual constant, and the uppercase G representing gassy. Now, what we can do is we can take some of our operators that we become familiar with, and we can make more complex singular statements. So for instance, if Fort Pierce blows, then Boulder rocks. We would translate that this way, right? If Fort Pierce blows, then Boulder rocks. Where lowercase f stands for Fort Pierce and the uppercase B stands for blows, because in that clause, blows is our predicate and Fort Pierce is our subject. Notice in the consequent, Boulder rocks, Boulder is our subject and rocks is our predicate. So by using our familiar horseshoe symbol, we can then translate the sentence, if Fort Pierce blows, then Boulder rocks. Let's look at another one. Smitty is either a chef or a drunk. So hopefully you recognize right off the bat that this is going to be a disjunctive statement. So in other words, we're going to use our wedge, or what some of you might recognize as a lowercase v. Smitty, of course, is our subject, and the predicates are chef and drunk. So when we translate this, it would look like this. Either Smitty's a chef or Smitty's a drunk. C standing for chef, S for Smitty, D for drunk, S for Smitty. Okay? So again, we're going to use predicate symbols, which are the uppercase letters A through Z for our predicates, and lowercase letters A through W, which we call individual constants, to represent our subjects. Let's look at some more complex examples. Marley either smokes or Tosh plays if Rita dances. Now there's a couple things going on in this particular statement. One, we see that we have a disjunctive statement going on in the first half. And the second half, we have Rita dances, but it follows the word if. So I hope you remember that when you see a statement following the word if, that it represents the antecedent of a conditional. So in this case, we'll have to flip the translation around so that the if Rita dance part comes first. That would be our antecedent. So our antecedent would be if Rita dances. Our consequent would be either Marley smokes or Tosh plays. So it would look like this. If Rita dances, then Marley smokes or Tosh plays. Again, the capital D standing for dance. It's our predicate letter. We use the individual constant R to represent Rita. We use the individual constant M to represent Marley, and the individual constant T to represent Tosh. And then we're going to use predicate symbol S and P for smokes and plays. Again, I want to make clear, notice that the Rita dance part is our antecedent because it follows the word if. So although our original statement says Marley smokes or Tosh plays if Rita dances, it's logically translated as if Rita dances, then Marley either smokes or Tosh plays. And that's really what's being said in the original sentence anyway. It's just turned around. Okay? So again, remember when you see the word if, whatever's following it is going to be the antecedent, with exception of the case of the word only if. We've talked about this before, I hope. You should have learned it when you were doing propositional, but if we have an only if, then that means it stays as a consequent. Here's another example. Rita dances and Tosh plays if and only if Marley smokes. Now hopefully at this point you recognize that the if and only if signifies a biconditional. So what we have here in our first half of the biconditional is a conjunctive statement. Rita dances and Tosh plays. If and only if Marley smokes. So it would look like this. Rita dances and Tosh plays if and only if Marley smokes. Now since this is a biconditional, it can be represented either way. Because what we're saying here is that Marley smoking is a sufficient and necessary condition for Rita dancing and Tosh playing, and vice versa. So again, hopefully at this juncture in the semester you recognize that if and only if signifies a biconditional, and the word and signifies a conjunction. So as in previous examples, you should recognize that we're using the predicate symbol D and P for the predicates dance and play, and we're using the individual constant R and T for the subject Rita and Tosh. Okay. Now let's move on to universal statements. Before I move completely on with them, though, I just want to make sure that we're clear about what's going on with the singular statements. Remember again that if it's a singular statement, that it's always going to involve a person, place, or thing. In this particular example, we have Rita, Tosh, and Marley. These are all people. Now, if I said Tennessee smokes, that would be a place, but it would work as well. So you might think, as a rule of thumb, that singular statements are always going to involve some sort of proper noun. All right. Now let's move on to universal statements. A universal statement makes a claim about every member of a class. So it looks like this. If I say all S are P, then my English interpretation would be to say something like, if anything is an S, then it is a P. So we would translate the English statement, all S are P, in Boolean terms as if anything is an S, then it is a P. In contrast, if I have no S or P, then we would translate that as if anything is an S, then it is not a P. So what we're trying to get at here is the right side here under interpretation is explaining to us exactly what we mean when we say the words that are under the statement form side on the left here. So when I say all S or P, what I'm actually saying is if anything is an S, then it is also a P. And if I say no S or P, then I'm saying if anything is an S, then it is not a P. Now let's talk a little bit about the universal quantifier. We're going to use lowercase letters x through z to form what we call universal quantifiers. Now the lowercase letters x through z we call individual variables. So remember, the lowercase letters a through w are what we call individual constants, and the lowercase letters a through z are what we call individual variables. So a universal quantifier is formed by placing one of these lowercase letters in parentheses. So for example, if I put an x inside parentheses, just like you see here, it would be translated as for any x or for all x. Remember, we're making a universal statement here. The universal quantifier is going to be used to denote a universal statement. And since a universal statement makes a claim about all members of a class, in this instance, the members of the class we're talking about are x, which would mean that every single x or for any x. This will become more clear when we do a few examples. First things first, though, and this is something that you need to remember. When translating universal statements, they are always translated as conditionals, which means we use the horseshoe operator when translating universal statements. Remember, conditionals are if-then statements. So anytime we translate a universal statement, it will always be translated with a horseshoe as a conditional statement. In addition, what we do is we add the universal quantifier to the horseshoe operator. So the horseshoe operator and the universal quantifier are combined to translate universal statements. This will become more clear when I show you an example. So let's look at one. All S or P would be translated as is on the right. I have a universal quantifier. I take one of my individual variables. In this case, we chose x. We put it in parentheses. Remember, that means for any x, or it could mean for all x. Then I have if s is x, then, or if x is s, then x is p. So the way to word this is to say, for any x, if x is s, then x is a p. Notice our original statement form. It says all s are p. So when we quantify it by putting the universal quantifier of x in front of the statement, what we're saying is for any x, if x is s, then x is p. Or alternatively, you may say for all x, if x is x, x is p. We'll look at another one. No s or p. Now in this instance I decided to use a z. Remember, we can use x, y, or z lowercase, which are individual variables. We can use any of our individual variables to translate or to make our quantifiers. So in this case I used a lowercase z. So here's my symbolic translation. It says for all z, if z is s, then z is not a p. So for any z, if z is s, then z is not a p. Please do remember that every time you translate a universal statement, it will always be in the form of a conditional. I know that might sound strange at first, but now you can probably get a feeling for why this is the case. Notice how we're saying it. For all z, if z is s, then z is not a p. So it is a conditional statement. It is an if-then statement. Okay? So let's look at some examples of translated universal statements. Statement, all beers are tasty. I will use the predicate letter B for beer and the predicate letter T for tasty. So for all x, if x is a beer, then x is tasty. Now you might think this is strange because earlier when we were doing singular statements, this statement would have seen that beer was a subject and tasty was a predicate. But notice, now that we're doing universal statements and we're quantifying them with the word x, x sits in for the subject. So both beer and tasty are now predicates. Think about it for a second. If x is a beer, then x is tasty. In that statement, x is a subject and both beer and tasty are predicates. So of course this statement states, for any x, if x is a beer, then x is tasty. What sets us off to know that this is a universal statement is the word all. I say all beers are tasty, so I'm making a claim about every member of the class of beers. So again, since we recognize it's a universal statement, we need a universal quantifier, which is simply taking one of our individual variables, lowercase x, y, or z, putting it in parentheses, and then translating the statement as a conditional. For all x, if x is a beer, then x is tasty. It's probably true as well. Okay, more examples. No novels are biographies. I'll give you a second to see if you can figure out what you ought to translate this as. Hopefully you got it right. For all x, if x is a novel, then x is not a biography. Notice, again, we know it's a universal statement because I'm making a claim about all members of the subject class. No novels are biographies. In other words, not a single one. Okay? So we're going to put a universal quantifier on there, and then we're going to use capital N for novels, capital B for biographies. My negation, of course, has to be in there because I'm telling you no novels are biographies. Now, it might seem a little counterintuitive at first. You might think that you should be putting in a negation in, but you're not. If you were to put the negation in front of novels in the translation here, if it would say all x, not the case in x, then then bx, what you would be saying is that for all x, if x is not a novel, then it is a biography. But that's not true. We know that just because it's not a novel doesn't necessarily mean that it is a biography. So it's properly translated this way. When we see no novels or biographies, what we're actually saying is that for all x, if x is a novel, then x is not a biography. Okay? Because no novels are biographies. Now let's move on to particular statements. Particular statements make a claim or an assertion about one or more unnamed members of the subject class. Statement form. Some S are P. How do we interpret this? What we're saying is that there's at least one thing that exists that is an S, and it is also a P. In contrast, if I say some S are not P, then what I'm saying is there's at least one thing that is an S, and it is not a P. I apologize for the typo. I see that it says at least one thins is an S and is not a P. That should say at least one thing is an S and it is not a P. Notice the difference between this and the universal statement. In the universal statements, I'm making claims about the entire member or about the entire class of things. Okay? In this particular statement, I am only making a claim about some or at least one. At least one. Okay? So some S or P tells me there's at least one thing that is an S, and it is also a P. Now you might recognize by the interpretation that the translation is going to be different for these particular statements. We're not going to translate them as conditionals, but rather as conjunctions. Now I'll talk about that in just a minute. First, let me introduce the existential quantifier. So just like the universal quantifier, we're going to use individual variables, which are the lowercase letters x through z, for forming what we call the existential quantifier. Now, existential quantifiers are formed by placing a variable to the right side of a backwards e in parentheses. So it'll look like this. Remember, the universal quantifier, we just put an individual variable in the parenthesis. For an existential quantifier, we're going to put the backwards e and then the variable just to the right side of it in parentheses. And this is translated as there exists an x such that, which will become more clear when we start doing some examples. But first, a bit about the translating. Particular statements are always translated as conjunctions. Now remember, our universal statements we always translate as conditionals. But in the case of particular statements, we will always translate them as conjunctions, which means we will use the dot operator when translating particular statements. The existential quantifier is combined with a dot operator to translate particular statements. So remember, with the universal quantifier, we combined it with the horseshoe to do universal statements. We're going to make a very similar move with the existential quantifier. We're going to combine the existential quantifier with the dot operator to translate particular statements. So for example, some S are P. That would be translated like this. I put my backwards e in next to one of my individual variables. In this case, I chose lowercase x. And then I'll have sx and px. This is translated as there exists an x such that x is an s and is a p. Notice the statement says some s are p. So that just means that there exists at least one x that is an s and it's a P. Another example. Some S are not P. There exists an X such that X is S and X is not a P. All we're saying with the existential statement, or what we also call particular statements, is that there exists at least one of these things. When I say some S are not P, what I'm telling you is that there's at least one doggone thing in the universe that exists, and it's an S and it's not a P. Notice, if I were to say all S are not P, then I would need to translate that as a conditional, because what I would be saying is that for all X, if X is an S, then X must be a P. But I'm not saying that in this statement. In this statement, I'm just saying some S are not P. In other words, there's at least one S out there, and it's not a P. That's why it's not translated as a conditional, because it's not a necessary condition of S that you're not a P. We're just saying that there's at least one instance in the universe where there exists an X such that X is S and X is not a P. So let's look at some examples of translated existential statements. We'll go back to our handy dandy beer example. Some beers are tasty. Now notice, in this case, I'm going to translate it as an existential statement because I'm not making a claim about all members of the class. Only some. So there exists an X such that that X is a beer and X is tasty. So in other words, what I'm saying here is that there's at least one beer that exists, and that beer is also tasty. Another example. Some beers are not tasty. Now, I probably disagree with this statement, but nonetheless, it'll be good for you to learn how to translate it. So some beers are not tasty. That means there exists an X such that X is a beer and X is not tasty. In other words, there's at least one beer that exists in the universe that's not tasty. So there exists an X such that that X is a beer and X is not tasty. Let's look at some more examples. Some novels are not biographies. There exists an X such that X is a novel and X is not a biography. There's at least one of them out there according to this claim. There exists an X such that X is a novel and X is not a biography. So let's talk about a general rule real quick. If the statement makes a claim about every member of its subject class, a universal quantifier should be used to translate it. If, on the other hand, it makes an assertion about only one or more members of this class, then an existential quantifier should be used. Let's take a look at some more complex examples. Not every foreign car runs smoothly. Now notice I put a capital F, capital C, and capital R to the right of this statement. I'm doing this to let you know what predicate letters we're going to use. On your exams, it should look the same. This way you already know that you're going to use F for foreign, C for car, and R for run smoothly. Now this is not the easiest translation, but hopefully it'll make sense once I show it to you. Notice what's being said in the symbolic translation here. I'm saying that there exists an X such that X is foreign and X is a car and X does not run smoothly. The first statement doesn't claim that every single foreign car does not run smoothly. What it's saying is that, hey, there's at least one foreign car out there that doesn't run smoothly. Hence, I can make the claim, not every foreign car runs smoothly. Think about it for a minute. How many foreign cars need not run smoothly in order for my claim to be true? The answer is one, right? If only one foreign car does not run smoothly, then that means it's true that not every foreign car runs smoothly. Again, this is a particular statement or an existential statement because I'm not making a claim about every single car. I'm just saying that there exists at least one X that's foreign and it's a car and it doesn't run smoothly. Let's look at another example. If all mysteries are interesting, then Hussein is not interesting. I'm going to give you a second to look at this. Now notice, we should recognize right away that we have a conditional statement here. I have an if-then statement, which means we're ultimately going to translate this with a horseshoe. Furthermore, the antecedent to this conditional is a universal claim, right? All mysteries are interesting. But notice, my consequent is a singular claim. It's not a universal nor a particular claim. It is a singular claim because it makes a claim about a person, place, or thing. Hussein is a person, a proper noun. So it will be translated this way. Remember, all universal statements will be translated as conditionals. So look at the first half. I have for all X, if X is a mystery, then X is interesting. Right? Notice my consequence says, if that's the case, then Hussein is not interesting. So my conditional universal claim is the antecedent to the larger conditional that has Hussein is not interesting as its consequent. So we could read this as, if for all X, if you're a mystery, then you're interesting, then it's the case that Hussein is not interesting. If all mysteries are interesting, then Hussein is not interesting. So for all X, if X is a mystery, then X is interesting, then Hussein is not interesting. Again, take note that M and I were used as my predicate letters, and I have the lowercase letter x as my variable in my universal statement. But remember, my singular statements, we just use individual constants. So the lowercase letter h stands for Hussein. Again, if all mysteries are interesting, then Hussein is not interesting. So we can see that what we're saying on the antecedent is that for all X, if X is a mystery, then X is interesting. And as a consequent, we're saying, then Hussein is not interesting. A bit more about something else. Let's talk about exclusive propositions for a moment. Statements that begin with the words only and none but are exclusive propositions. When these are translated, the term occurring first in the original statement becomes a consequent in the symbolic expression, and the term occurring second becomes the antecedent. So in other words, you need to pay attention for the indicator words only and none but. We will look at some examples from this. So let's say I have only close friends were invited to the wedding. And we're going to use I and C as our predicate symbols here. I meaning invited, C meaning close friends. Notice, when I say only close friends were invited to the wedding, what I'm actually saying is that if you were invited to the wedding, then you were a close friend. So it will be translated this way. For all X, if X was invited to a wedding, then X is a close friend. Let's step back for a second. Remember, read this. When these are translated, the term occurring first in the original statement becomes the consequent in the symbolic expression, and the term occurring second becomes the antecedent. So when we look at this example, we see that the term that occurs first is close friends, and that invited to the wedding occurs second. Now again, since we always translate universal statements as conditionals, they will always include an antecedent and a consequent. Because this is an exclusive proposition, which is indicated by the term only, we know that we need to flip this around to say, if for all X, if X is invited, then X is a close friend. Okay? Notice the statement doesn't say that if you're a close friend, then you're invited. It says only close friends were invited to the wedding. This does not mean that every single close friend is invited. It just means of those who were invited, they were close friends. Let's look at another example, this one using the none but phrase. So none but gentlemen prefer cigars. Again, we're using P here as our predicate symbol for prefer cigars, and we're using G as our predicate symbol for gentlemen. Again, because it's an exclusive proposition, this is going to get flipped around. So gentlemen will turn into our consequent, and prefer cigars will become our antecedent. So it will look like this. For all X, if X prefers cigars, then X is a gentleman. None but gentlemen prefer cigars. That means for all X, if X prefers cigars, then X is a gentleman. Notice, we're not saying that every single gentleman prefers a cigar, which would be the case if we were to translate it as for all X, GX implies PX. If we were to say for all X, GX implies PX, we would actually be saying that if you're a gentleman, then you prefer a cigar. But that's not what's being said here. What's being said here is that if you prefer a cigar, then you must be a gentleman. But that doesn't necessarily mean that every single gentleman that's out there is going to prefer a cigar. What it means is that every single person that prefers cigars is a gentleman. Thus, we translate it as for all X, if X is P, then X is G. Let's look at some more complex examples. Now, this one's quite tricky. Only snakes and lizards thrive in the desert. We'll use T for thrive, S for snakes, and L for lizards. Now you might be tempted right off the bat to think that we're going to translate snakes and lizards as a conjunction. The problem with this is that there's not such a thing that is both a snake and a lizard. Or at least maybe there is, but in this sentence we're not talking about a thing that is both a snake and a lizard. What we're talking about is two different things, snakes and lizards. And what we're saying, those are the only things that thrive in the desert. So what we're really claiming here is that if you thrive in the desert, then you are either a snake or you are a lizard. So look at this translation. For all x, if x thrives in the desert, then x is a snake or x is a lizard. Now remember the talk on exclusive propositions. This statement starts with the word only. That should immediately indicate to us that we're dealing with some sort of exclusive proposition. And when we're dealing with exclusive propositions, as we've noted, the statement that comes first will be our consequent, and the statement that occurs second will be our antecedent. So in this case, the snakes and lizards part has to be switched to our consequent, and the thrive in the desert part becomes our antecedent. Now the reason that we translate the snakes and lizards as a disjunct is because we're not saying that if you thrive in the desert, then you are a snake and a lizard. What we're saying is that if you thrive in the desert, then you are either a snake or a lizard. Okay, so I'll read this as it's translated symbolically. For all x, if x thrives in the desert, then x is either a snake or x is a lizard. Look out for these types of statements. They're a bit tricky, I understand that, but hopefully they make some sense. Let's look at another one. Neither Hambly nor Christine are rodents. R is my predicate symbol, standing for rodent. Hopefully, if you take a moment to look at this, you'll realize that Hambly and Christine, particularly since they're capitalized, this is a helpful indicator, must be singular statements. In other words, they are a statement about a person, place, or thing. In this particular case, Hambly and Christine are both people. So this is not a universal, nor is it a particular / existential statement. It is a singular statement. So it will be simply translated as this. It is not the case that Hambly is a rodent or Christine is a rodent. Neither nor, take note of this, neither nor is translated as a negated disjunctive statement. In other words, it means when you see neither nor, you should recognize right away that you're going to have a disjunctive statement inside of parentheses with a negation sign to the left. Notice what this says. It says that this whole thing is not the case. It's not the case that either Hambly or Christine are rodents. So neither Hambly or Christine are rodents. Okay? So recognize this, just make a note of it. When you see neither nor, you're going to translate it as a negated disjunctive statement. If my parentheses were not around this, and it just said not RH or RC, then it would be translated as it's not the case that Hambly is a rodent, or it is the case that Christine is a rodent. So it's very important that the parentheses are in place. Let's look at some more. I'm steadily getting more complicated here. Be sure to do the practices in the book. A room with a view is available. Predicate, we're going to use the predicate symbols R, V, and A to respectively stand for room, view, and available. Again, I'll give you 1 second to see if you can figure out how to translate this. Ask yourself, is this universal, existential, or singular? The answer to that question is that it is existential. I'm making a claim about at least one room. I'm saying there exists a room in the universe with a view and it's available. So it will be translated this way. There exists an X such that X is a room and X has a view and X is available. There exists an X such that X is a room and X has a view and X is available. How about another one? Only talented musicians perform in the symphony. Now recognize the word only is in there. What does this mean? Exactly, it's an exclusive proposition. So the first part will be moved to the consequent, and the second part will become our antecedents. For all X, if X performs in the symphony, then X is talented and X is a musician. That's exactly what's being said here. Only talented musicians perform in the symphony. T stands for talented, M stands for musicians, and P stands for perform in the symphony. So what do we have here? For all X, if X performs in the symphony, then X is talented and X is a musician. Again, don't forget that word only indicates to us right there that it's an exclusive proposition, and thus that first part will be moved to the consequent. Now let's look at what I'll call the beast. This is a really complicated translation. And no, I don't expect many of you to figure it out right off the bat, but hopefully once talking through it, you'll get an idea. So here it is. Green avocados are never purchased unless all the ripe ones are expensive. So we have G for green, A for avocado, P for purchased, R for ripe, and E for expensive. Now, something we haven't talked about, but perhaps you've picked up from the book, I hope, is that we translate the term unless as a disjunctive statement. In other words, we use the wedge or the lowercase v as our operator with the term unless. So we can see that this particular translation is at least going to involve a disjunct because we have the word unless in there. So let's take a look. Yes, it's big. But let's take it one part at a time. So notice what our main operator is. Our main operator is the wedge, right? It's a disjunct symbol. We get this from our unless. So we have two sides to this wedge. On the left side, we have green avocados are never purchased. And on the right side, we have all the ripe ones are expensive, where the disjunct symbol itself replaces the word unless. So let me just read the translation, and then we can talk through it some. So the translation says, for all X, if X is green and X is an avocado, then X is not purchased, unless for all X, if X is ripe and X is an avocado, then X is expensive. So let's take the first side. Let's look to the left and look at the sentence again. Green avocados are never purchased. So what I have here is that for all X, if X is green and X is an avocado, then X is not purchased. Easy enough. Now let's look at the right side of this disjunct. All the ripe ones are expensive. The ripe ones refers to avocados, of course. So what's being said here is that for all X, if X is ripe and X is an avocado, then X is expensive. So putting the unless in there, what we're saying is that for all X, if X is green and X is an avocado, then X is not purchased unless if for all X, X is ripe and X is an avocado, then X is expensive. I know that this one's not that easy. Take the time to try and work through it yourself, get to where you can understand why it's translated this way. But, the first thing to note is that unless is going to be translated as a disjunct. Once you recognize that, then what we can do is just each side of the disjunct. On the left side, it seems pretty simple. Green avocados are never purchased. Again, for all X, if X is green and X is an avocado, then X is not purchased. On the right side of our disjunct, all the ripe ones are expensive. What's that saying? For all X, if X is ripe and X is an avocado, then X is expensive. Okay. Take some time to practice some of these. You may see something like this on your exam. Last but not least, I want to talk a little bit about bound versus free variables. So in order to do that, I need to introduce a new term to you. Statement functions. A statement function is the expression that remains when a quantifier is removed from a statement. Now remember what my quantifiers are. We have two different kinds. We have the universal quantifier and we have an existential quantifier. So for example, look at this. It says if x is n, then x is not b. Notice there's no quantifier here. Remember, my quantifier would be located directly to the left of this statement. So you would see one of my individual variables inside a parentheses to the left of this if there was a quantifier there. Since there's no quantifier there, we call this a statement function. So statement functions are expressions that do not have quantifiers. Now, quantifiers govern only the expression immediately following it. So it's real similar to the negation sign. Remember how the negation symbol affects statements. Well, the quantifiers affect them in a similar way. Not that they negate them, but they only govern the expression immediately following it. So let's look at an example. If I have for all x, if x is n, then x is not b, then that means that the universal quantifier governs the entire statement function in parentheses. Namely, if nx, then not bx. So this quantifier governs over the entire conditional because it's in parentheses. However, in this statement, for all x, nx implies not bx, the universal quantifier governs only the statement function in x. Notice, if I had parentheses around it, then it would govern the entire statement. But since I don't, it only governs the thing immediately to its right, and that's in x. So now let's talk about bound versus free variables. You may have a clue already what this is, but hopefully I can make it clear. In the following statement, for all x, nx implies bx, we say that the variable in the statement function nx is bound, but the variable in the statement function bx is free. The reason we say this is because nx is governed by the universal quantifier there, where bx is not. So what we mean by bound and free is whether or not the variable that we're talking about is being governed by the quantifier. So in this case, since the only variable being bound or being governed by the quantifier is the variable attached to the n, it's considered bound, whereas the other one is considered free. So let's look at some more examples. For all x, if x is an n, then x is a b. What do you think is bound? Hopefully you answer that both the variable in the statement function nx and bx are bound. Why is this? Because that universal quantifier governs the entire statement due to the fact that there are parentheses on it. Let's look at another one. There exists an x such that z is n and x is b. Now this is a little bit different than what we've seen so far. Notice I have two different individual variables in my conjunction here. I have a z and an x, which means that only the variable in the statement function bx is bound. The variable in the statement function nz is free because in my quantifier, the variable that is in use is an x. So that x governs everything to its immediate right that is an x. So it governs the bx, but it does not govern the nz. Hopefully a few more examples will make this more clear. So let's look at this one. For all x, not nx, implies bx. Again, this one should be fairly straightforward, but the variable in the statement function not nx is bound, but the variable in the statement function bx is free, and that's because, again, quantifiers only govern those statements immediately to their right. Now, had I had parentheses around this entire conditional, then that would mean the whole thing was bound by that x. But since I do not have parentheses, it's the case that only the not nx is bound. Let's look at another example where I switch up my variables. So my quantifier here is a z. I say for all z, If X is not N, then X is B. Do we think that this statement's bound or free? Hopefully you said free. Both the variable and the statement function not nx and bx are free, specifically because in this case the universal quantifier is a z. So it's only going to govern other instances of z that follow immediately to its right. Since there are no z's in this particular statement, both the not nx and the bx are free. I hope that this has helped out some. Predicate logic I know is not the easiest, and we're not going to go through the entire chapter. But at the very least, we're going to get to where you learn some translations, and we're going to do some of the more simpler logical proofs. Okay, everybody have a great day, study hard, and hopefully you will succeed. Bye now.